Welcome. Glad everyone could make it in this morning. My name's Chris Jansen with BASF. My colleague here, Brian Oman. We're here to talk about spray foam. We did one of these last year, focusing on the commercial market, commercial buildings, Part 3 buildings, and we got a lot of questions from the residential side of things, Part 9 buildings. So that's why we decided for this year, we'll put in the Part 9 and talk a little bit about some residential stuff and where you can use spray foam. And, you know, if you guys have any questions with regards to spray foam applications, where it can be used and all that kind of stuff, feel free to ask us at the end. We got about 35 slides or so we should be done in half an hour, 40 minutes, and lots of time for questions if you guys have any. So some of the stuff we'll be talking about, basically just the very basics about spray foam. What is spray foam? How it functions as a vapor barrier, and kind of explain why you can get rid of 6 mil poly when you're using spray foam in your walls, and how to detail properly to have a complete air barrier system in a retrofit wall situation. How to verify that the installer that you're hiring, the contractor you're hiring, knows what they're doing. Very important when you're doing retrofit type of work, because you got homeowners there. You want to make sure that you want to make sure you're hiring a good trade. We'll talk about where you can use spray foam for interior retrofits, and then we'll go to some exterior retrofits and how you can kind of do some, when you're going into the wall, and how you can insulate to very nice high R values, make a nice airtight home out of an old home. So starting off, so what is spray foam? It's a high performance insulation consisting of an isocyanate side and a resin side. Everything gets mixed together. You guys are all sitting on polyurethane foam right now as well too. Polyurethane is everywhere. It was invented back in the 30s, it was discovered back in the 30s. The first building that's had polyurethane in it was around the 1960s era, and it's being used almost everywhere now, from cars to shoe soles to the spray foam that's being used to insulate buildings and other types of products for insulated buildings. So it provides an air seal structural strength because it's going into the wall assembly there. And then it also provides moisture and condensation control just based on some of the physical properties of the closed cell spray foam. So spray foam reacts very quickly. It goes from the liquid form, it combines in the gun, and it reacts in about 5 to 10 seconds on the wall, so that it's hard to the touch at that point. So yeah, the resin and iso component, that's the inside of a spray foam truck. So they put the barrels onto the truck. The product gets driven to the job site. They have about 300 feet of hose there, and then that's the proportioning unit. So the proportioning unit is what makes sure everything is done on ratio, that 1-to-1 ratio. So it heats up the equipment, it pressurizes it, and it delivers it through this big blue hose. Actually has 2 hoses in it to deliver the isocyanate and resin to the gun where it mixes. If there's any kind of off ratio or hiccups or anything that's happening in the equipment, it senses that, it shuts everything down, and then a spray foam installer is going to know to go back, figure out what's going on, fix their equipment, make sure that everything that's on the wall is on ratio. So, and one of the big things when they're using this kind of equipment, when they're using any kind of spray foam, is they need to see where the foam's going into. So we hear a lot from some general contractors about using a magic wand to put the foam into this hidden corner that nobody can see and just assume it's going to be okay. In order to get a good spray foam installation, you have to be able to see where that foam is going. You have to be able to see that substrate, and the contractor, the installer needs to be able to see the foam rise. And of course, then the building inspector needs to be able to see and look at it to make sure that it's everywhere it's supposed to be. It's hitting the studs. It's properly adhered everywhere. So, you see every now and then on YouTube, the drill and fill applications where they drill holes into the drywall, put their spray foam gun in there and pull the trigger. You don't want to do that. It's not advisable. It's actually not recognized in the building code because it can't be inspected. So these types of applications, the issue with it is you don't know what's in that stud cavity if you're just shooting foam in there blindly and you're pulling a trigger. So you don't know, are you actually filling that stud cavity with insulation? Are you leaving voids? What's happening with the vapor barrier properties, the air barrier properties, because you can't see what's going on in there. So if you're going to use spray foam, any kind of retrofit type of stuff, you want to make sure you're taking the drywall off so you can see what's going on inside that stud cavity. So there's 2 different types of spray foam primarily for residential applications. The open cell low density spray foam, which is around a 1/2 pound density nominal. And then what we'll be talking about primarily today is a closed cell spray foam medium density, which is around a 2 pound nominal spray foam. The open cell This is the light fluffy stuff that's easy to compress and expands a lot when it goes into the stud cavity. It's used a lot in garage ceilings in the southern Ontario area. It uses water as a blowing agent. The water reacts with the isocyanate, actually produces carbon dioxide, and that carbon dioxide is what causes that foam to rise up. Whereas the closed cell foams, the medium density, they use refrigerant as a blowing agent. So right now we're on hydrofluorocarbons, and we're moving over to low GWP products, HFOs, hydrofluoroolefins. I'm a chemist, so that's why I'm throwing these names out there. And so the refrigerants, they're in the resin component. The foam, when they react on the wall, they create heat, and that causes these refrigerants to turn into a gas form, and that's what causes, or that's what helps the foam rise, and that's what actually gives it the higher R values that you get, because it's got this refrigerant in there that's giving a higher R value per inch on that foam. Right now we're seeing R values getting up towards 6.5, but as the industry is moving over to the next generation blowing agents to meet our 2021 Montreal Protocol requirements with low GWP emissions, then the foam's going to start coming down to around that 5.5 inch per inch range. And that's just because it's the nature of new chemistry, or the new blowing agents in there. They just have a little bit lower R value in them. So, and then one of the big benefits, other than just using it as an interior insulation, that closed cell foam can do over open cell foam is it can be used in an air barrier system. It can detail into the stud cavities. You detail it properly on the inside. You can use it as an air barrier system. It has vapor barrier properties because of its closed cell nature. And again, closed cell nature is very low water absorption. So it can take water. You don't want it sitting in water. It shouldn't be immersed in water, but it can take a rain, or can take flooding, that kind of stuff, as long as it's allowed to dry out afterwards. And because of all those things, it can be used on the exterior as continuous insulation. This is used a lot more in commercial buildings, hospitals, schools, those kinds of buildings, where they spray the foam on the exterior of the building and basically wrap the house with continuous insulation. We're going to show you some applications towards the end where it can actually use a spray foam as continuous insulation, and how to incorporate spray foam into exterior retrofits like that. And also, because it's medium density, it's got a higher compressive strength, around nominal 25 to 30 PSI. That's going to give you more structural strength in your wall cavities as well too. So some of the standards that are referenced in the national and provincial building codes is the material standard for foam, so 705.1, and the installation standard for foam, 705.2. So this is the stuff, as a manufacturer, I make sure we meet the material standard so that it meets the building code. The installers install it as per the application standard to make sure it meets the building code. And this is all overseen by a new standard that's coming through the system now, the 718 standard, which is basically a site quality assurance program standard. And it ties in our third-party certification bodies that oversee the installers, license the installers to make sure that everything's being done on site properly. So moving into some of the building science aspects before we talk about why you can get rid of the vapor barrier, just cover off on some stuff basically. I guess before I go into this, how many builders do we have in the room? Just a quick show of hands. Architects, engineers, any energy consultants? All right. So we'll talk a bit about this. Just wanted to gauge the audience, see who's here. So vapor drive, basically you have moisture. It's a day like today, you're going to have a high humidity content on the inside in the warm, and that vapor is going to want to move through the wall to get to an area of low concentration outside. It's a slow process relative to air leakage, which has a much higher pressure differential. And there's research done by National Research Council about 40 years ago that shows that basically air leakage accounts for about 1,000 times more moisture movement across the wall assembly than a vapor drive does. So it can move a lot more moisture into that wall assembly with air leakage, and it can also relocate that dew point. When you do your calculations, where's your dew point going to happen? It's usually happening somewhere within that insulation in a typical wall cavity. If there's air leakage happening, though, it can move that insulation all the way to your vapor barrier 6mm poly right by your drywall, and that can start causing condensation if that gets too cold in the wintertime. So some of the properties you're looking for on vapor barriers So the vapor barrier, of course, 6 mil poly or spray foam, it goes up there, prevents water vapor from entering into the wall assembly, and it's always placed on the warm side of the insulation. And it actually doesn't need to be continuous. You can just put it up there, and a discontinuous vapor barrier doesn't need to be taped or stapled, or there's some gaps in there in between studs. Technically, it's not that big of a deal from a vapor barrier and vapor drive standpoint. But if you're relying on some of those components as part of your air barrier, that's where you need to have 100% continuity within the whole building, because if you have a little square inch of hole in your air barrier system, then that can allow moisture to drive through your wall assembly and get condensation in that wall assembly. And just one little area, that can be enough to cause a big headache for the homeowner and have to go back and work on stuff. So the air barrier, it can be placed anywhere within the wall assembly. And like I said, the big thing is continuity. So same thing when you're going from an attic to a wall, you want to make sure that the air barrier system that's in the attic gets tied into the wall air barrier system and there's no gap there. Otherwise, you can have airflow going through the top plates as an example. So the Ontario Building Code, section 925.42, it recognizes that a vapor barrier, defines a vapor barrier as anything less than 60 nanograms per Pascal second meter squared, and attested to the E96, that if you meet that, then you're a vapor barrier. So foam, and then it goes on to say that where foam plastics used as the insulation, where foam plastic functions as a vapor barrier, it needs to be thick enough to meet that 60 nanograms. So that earlier standard we talked about, that 705.1, in order for a spray foam to meet that standard and hence meet the building code, we test the water vapor permeance at 2 inches for that standard. So basically that 50 millimeters, 2 inches, any foam that meets the 705.1 standard that's in the building code, it qualifies as a vapor barrier at 2 inches. So, same thing, 6 mil poly, it also functions as a vapor barrier. So the closed cell spray foam, 1 square foot of it will function as an air barrier material. And that's really, when you're testing an air barrier material, that's really the size that it is, about 1 square foot. And does it allow air leakage to go through there? That's the same test that 6 mil poly goes through, is 1 square foot, does air leakage go through there? But then you have to properly detail it on site to make sure that it fits into your air barrier system. And with closed cell foam, it's, we'll show you some details with that, but basically you're using caulking in around studs to make sure that any of the wood-to-wood joints are sealed up properly. 6 mil poly, you got to tape and caulk the seams, overlap the 6 mil poly properly. It's prescriptive in the building code on how you need to do that. The drywall's got to be fastened properly onto the studs afterwards. So there's a whole bunch of steps involved to make sure that 6 mil poly functions as the air barrier system in the house design. You can go on the exterior as well and use peel and stick membranes and do a full wrap with peel and stick membranes onto the exterior sheathing as well to get your air barrier system. But it's very labor intensive to do it properly. There's lots of steps involved, and it's a very easy process to make mistakes in, essentially. So one of the benefits that closed cell foam does as well too is it functions as the insulation, and it increases the temperature of that first condensing surface. So all the building science stuff that I sat through before, some of these seminars years ago that I sat through before, is it talks about basically as your vapor drive, your humidity starts coming from the inside in the warm building. Your dew point is going to be insulated, or your dew point is going to be located within that bad insulation somewhere, but it's not going to condense. If you have a vapor drive going through that bat, it's not going to get condensed in the actual bat. It's going to hit the first surface that's impermeable. So be it OSB or sheathing, it's the first surface it hits that's below temperature, that's where you're going to get your condensation on it. So spray foam, by using spray foam in place of the bats there, is you don't need the 6 mil poly, because the spray foam now is that first layer where you're going to have condensation. And because that spray foam is the same temperature as a drywall, which is the same temperature of the inside of the building, you're not going to have any condensation on that spray foam. So the fact that it's vapor impermeable and it doesn't allow moisture transfer through there, and it's also at the room temperature, that's why you don't need a 6 mil poly with spray foam. Now, if building inspectors are asking for 6 mil poly, they might be looking for an air barrier. And that's where doing the proper detailing, and the code's starting to recognize this with using caulkings to detail spray foams without the 6 mil poly to get a complete air barrier system. That's how you can meet those requirements. So, all right. So moving on to how do you pick your contractor to make sure that you're getting somebody that knows what they're doing? Well, again, with the new standards that are coming in, we're using registered contractors and certified installers. So for BASF as a supplier that sells our wall-tight spray foam to the industry, to you guys, in order for us to sell to a registered contractor or a contractor that's going to spray it, they need to be registered in our system. They need to meet certain requirements. So we don't sell to people that don't meet these requirements. We have a third-party certification organization. We're just showing some examples of their cards. So we use Caliber. There's a couple other certification bodies in Canada that do the similar types of processes, but they need to be registered with that, and that means they need to have liability insurance in good standing with WSIB. They need to be a properly incorporated company, and one of the biggest things with them is they need to employ a certified installer. So if you don't actually employ a certified installer, you can't buy spray foam. And these cards, these are available. So if you have a sales guy coming to your job or you're talking to a contractor on the phone, is they should be able to give you their registered contractor number. And then if you have the cards, you can actually just scan it with your phone. A QR code goes to the website, says if they're in good standing or not. And same thing with the spray foam applicator. When he gets to the job site, is if you're a general contractor or have one of your guys on the job site, you just ask before the guy gets started, sets up, just ask him for a certification card, do a quick little scan on the QR code, goes to the website, and it tells you if they're in good standing or not. And the reason why the certified installers are important is they're trained. Typically, they're trained by the manufacturers on how to use our products, but then they're tested and certified by our third-party certification organization every 5 years to make sure that they actually retain that knowledge and know what they're doing. And this is a ISO 17024 accredited certification program. So it's not just throwing words around. There's actually standards in behind these certification standards, supported by the government, supported by the building code, to make sure that the trades that are showing up on site to do your spray foam application, they know what they're doing. And the reason why some of that's important, some of the responsibilities of the certified installer on site is one of the biggest things, other than just putting the foam in there, is they're responsible for people's safety within that spray foam area. So you can see the guy spraying foam, he's got his Tyvek coveralls on, he's all suited up, spraying foam, lots of PPE, fresh air, and all that kind of stuff. So he's protected. The reason why they're protected in the spray area is because they're atomizing the isocyanate and resin. It's reacting as it goes onto the air to polyurethane foam and reacting on the wall. And typically, with proper ventilation rates, is the risk of inhaling these particles are gone after about an hour. The particles that are produced from the spray foam application, they can be asthma inducing, basically cause occupational asthma if you're not wearing the proper PPE. And that's why the installers are trained to make sure everyone's not in the spray area. So they should have signs up, warning tape posted, warning signs, and isolate the area from other trades that might be on site and have ventilation provided for that. And with all that stuff, that's basically just making sure that the site's properly controlled and everyone's safe on there. And they're also responsible for job site quality control. So here's an example of the daily work record that our installers use. So they have everything from the project address, the date that they're installing it, what kind of environmental conditions, temperatures, humidities, substrate conditions, anything that can affect the spray foam application, what their machines are set at, and actually their quality control, where they test the density and the adhesion of the product on site. And then when that part's done, when they're done the job, these work records get sent to BAS, get sent to our third-party certification organization, Caliber, in our instance, to make sure that everything's proper. They can audit these work records and see, is there anything missing on that should be followed up from the manufacturer. Also, building officials are also starting to ask for these as well too, is basically documentation that the foam's installed properly. And then the installers at the end of the job, they'll leave what's called a job site label behind, which is basically name of the installer, company's name, date that the product was installed, what the R value was, what product was installed, and where was it installed. And all this kind of helps as a supporting evidence or supporting documentation for a lot of manufacturers will have Green Guard Gold certification. So that's basically making sure that the foam is classified as a low emission building material. So it's Green Guard Gold means it's safe for sensitive individuals, like in schools, in hospitals, that kind of place. So getting into the retrofit type of stuff where you can use foam, again, you guys, you're the professionals, I'm sure you're all building owners, or most of you are homeowners as well too. So I want to give you some talking points when you're talking to a homeowner, to your clients. What are the benefits for them for using spray foam? One of the biggest things that you want to convey to the client is spray foam provides comfort to the homeowner, environmental comfort. When they're in the room, it's more comfortable room to be in. It's a hard thing to quantify, but it is more comfortable. And the reason for that is because you're getting your insulation, your air and vapor control with one product. So what that does is, because it's reducing the drafts in the room, so now you don't have cold spots, and it also improves the durability of the building envelope because of the air sealing properties of the foam. Now you're not going to have to worry about moisture or dust coming in from outside, no air leakage carrying moisture or dust onto the inside. So you don't have to worry about mold or any kind of environmental contaminants from the outside of the building getting inside, affecting the indoor air quality. So, and they're using certified installers to put this in there. It's not just any trades going in there. You know, drywall guys who do a great job putting up drywall, but they'll also put in the bats and the poly, but they're not doing that every day. Versus spray foam installers, they're installing spray foam every day. Some of the steps that are involved with the actual spray foam application, again, from the design standpoint, from the start of the building project, one of the biggest things in my experience has been make sure that the spray foam is included on the drawings that go for the building permit. As we know, it meets the building code, but a permit official, a building official, when they walk in to do an inspection on the job, if it says that there's bat and poly there and they walk in and they see spray foam, they're going to put their arms up and say, wait, you got to do a new permit application, go back and all that kind of stuff. Slow everything down. It has nothing to do with the installation quality of the foam, it's just because that building permit's different. Whereas if it's put on the drawings or there's a change order put on the drawings that are submitted to the building officials, the building office, then they'll redo the permit, they'll review everything on site or review everything in the office, sign off on it, and then the building inspector walks in the project, he looks up, sees spray foam up there, looks at his permit, everything's fine, gets a daily work record, signs everything off. So that's one of the most important things to make sure you have a seamless installation, is to make sure that it's showing up on the permit drawings. One of the things, if you're doing a retrofit, is involve an energy advisor. Is they can help you with properly sizing the HVAC system for a higher energy building envelope. They'll help you get the HRV system, make recommendations on what kind of HRV system, so that, because you're now making the envelope airtight, is you want to make sure that there's air changes happening in there. And they'll also help the homeowner figure out what kind of rebates they can get for where the insulation is going. If you're on a budget, an energy advisor can help kind of identify where the best benefits are to get that spray foam installed. And then you can also do a blower door at the end of it as well too with that energy advisor, and show the homeowner what kind of improvements you had on that building envelope there. Make sure you hire a reputable spray foam contractor. Make sure that when you're talking to them and they're giving you your quotes, that they have that registered contractor number. Check your certified installer when they're on site. And they should make sure that they inform any occupants or trades that are going to be on site at the same time as a spray foam application to either leave the area or give the spray foam installers the house for the whole time, depending on how big the project is. And you want to make sure that that area is accessible. As a general contractor, is you don't want to have drywall all the way up to the wall. They need about a 3 to 4 feet area to move around the walls. If they're working on the ceilings, they're going to have to be able to get their scaffolding in there, so you need clear floors. So again, based on retrofit applications, that can be challenging at times, but it's just one of those key little things to keep in mind. So some of the easiest type of retrofits, and this is happening every day in the city of Toronto, where you take a home from the 40s and 50s, they gut the interior and they start putting spray foam on the inside. Basically walls above grade. After electrical is completed and passed, any kind of structural stuff is completed and passed by the building inspectors, then you can bring your spray foam trades in to spray insulation on the walls. In a retrofit, one of the benefits of using spray foam versus just going back with a bat and poly is you get a higher R value in that existing framing. So you might not need to frame out anymore if you need to put an R24 in there. With bats, you're going to have to frame it out. With spray foam, you can get about an R20, R22 pretty easily into an existing 2x4 assembly. So, and as far as air sealing, that's where you want to make sure stuff like this, where you have corner studs, top plates, and the floor, don't have the floors on there, but where the bottom plate meets the floor, that's where you want to run a bead of caulking, either an elastomeric polyurethane type of caulking or an acoustical type of caulking, to make sure that all these wood-to-wood joints are sealed up, and the spray foam on the inside, that's going to seal the majority of the building and the wall for air leakage. Moving down to the basements, again, this is one of the biggest bangs for the bucks. This is actually pretty easy retrofit for newer homes as well too. There's probably lots of, I know my home doesn't have a finished basement. So if I were to do a finished basement at some point and got the budget and the time to do it, then yeah, use spray foam on there. One of the key things on this, though, if you are doing basement renovations and planning to use spray foam on there, is make sure if there's any leaks in that foundation, that's fixed first. So spray foam can go over a leaky foundation. I've seen it done before too, where they put spray foam over a crack in the foundation. But if water's coming in there, the spray foam's really just a Band-Aid. It's going to hold the water back, but give it 5 or 10 years and you're going to start having a wet spot on that drywall. So you want to make sure that any kind of leaks in the foundation are addressed properly. Otherwise, you're just putting a Band-Aid over it. So when you're spraying when you're getting ready to spray, is you want to offset the studs. We're kind of detailing that here a little bit, and you can see that in the picture. You offset the studs 1.5 to 2 inches, and that allows for continuous insulation then to go in behind that and give you a higher effective R value in that wall assembly. Same thing as doing the rim joists up here is by offsetting the studs. That allows the foam to wrap around, and again, you're getting your air seal from the spray foam on the bottom plates there, on the rim joist, and it wraps around down the wall and provides a nice air seal into that building envelope. So, and then one of the things is when you're doing this is spray foam needs to be covered by a by a thermal barrier. Is you can't leave the foam exposed to the occupants to see. It needs to be covered by drywall or some kind of cementitious thermal barrier to make sure that it meets the requirements of the building code. So building inspector won't issue final occupancy until the foam's all covered. One of the benefits of doing spray foam in the basement, other than just air sealing the rim joists, is it gives the homeowners warm floors on the first floor above the basement, but also because it's controlling the humidity level now in the basement, you're not getting as much vapor drive coming through the walls. It gives it more comfort as well down in that basement. It gets rid of that humidity, that musty odor, that musty feeling that you get in basements sometime. If they're running a humidifier in the basement, dehumidifier in the basement, I should say, it's not going to be running as much because you're controlling that humidity now by using a closed cell product like spray foam. One of the other ways, again, if you do have a leaky basement, you're excavating on the outside, is to address the leak is, well, you can spray your foam on the outside as well too. So spray foam right now in the Ontario Building Code, you still need damp proofing, you still need a protective dimple membrane over top of the foam. But now you're putting your insulation on the outside, you don't need to worry about the thermal barrier protecting the foam on the inside. If the basement's already finished, but it's got a leak, it's an excellent opportunity to add more insulation into that below grade there. And then of course, if you put when you put a dimple membrane over top of the foam, that also provides protection from backfilling and doesn't damage the foam then. Moving up into the roof lines is in an attic situation. This is actually one of the very popular programs, or with the Green On program that just expired. This was actually a very popular procedure that was done, where the spray foam contractor would come in with a removal truck, basically a vacuum truck, and they would suck out all the existing insulation. That could be probably 3 or 4 different levels. We got a great picture of that from a 1960 era home later on. They remove the existing insulation. If there's no vapor barrier there might not be a vapor barrier. If there is, they'll take that out. It gives the homeowner or the builder a chance to fix or upgrade any electrical in the attic, because now it's wide open, it's easily accessible. Address any soffit venting requirements that might need to be upgraded as well too, because again, it's easily accessible in there. Any kind of bathroom exhausts that aren't going in the right direction or aren't sealed properly, Now's the time to do that. And then the spray foam installer would come in. They would spray typically about 2 inches of foam down directly onto the drywall. Again, that gives you your vapor barrier, that gives you the air sealing properties, and it gives you about an R12 insulation on there. And then to be cost effective, because you already have your air seal, you can go back with either bats or blown in cellulose on top of it to bring it up to your R50 or your R60 requirements. Going into Cathedral Ceilings, probably not as much of a retrofit type of application, but this is one of those areas in the code that's kind of a gray area. That's why we're showing the venting. So the building code, the national code and the Ontario code, they both say that venting in a cathedral ceiling or venting in an attic is not necessarily required. It should be done, but it's not necessarily required if it can be proven otherwise. So this is where you want to make sure if you're going to use spray foam in an unvented attic situation where you don't have these baffles there, the soffit baffles there, that's where you want to make sure it's on the building drawings and that the building department has already signed off on it. Because if they come in there and they see spray foam, they're expecting to see batten poly, they're going to say, well, how do I know that's vented? Because that's what it shows in this drawing. I don't know what else is going up on there. So get me an engineer in to say everything's fine so I can put that note into the file. So by having everything on the drawings there, then that kind of puts the building inspectors at ease. One of the things that comes up with this is usually as you're taking stuff apart and adding maybe a second floor onto a house line and you're putting new roofs in there, as everything's coming together, you might be planning to do a batten poly insulation with venting. All of a sudden, as the roof lines are coming together as a builder, you start realizing, well, we can't vent this. So because we can't vent it, the way that the roofs are lining up, we can't really vent very well up there. So let's just go use spray foam because then we can make it an unvented attic. Again, that's fine, but just make sure that you get your drawings updated to reflect that. So garage ceilings, again, there's lots of those 1960s and 1970s era homes where there's room above a garage. So again, it's an easy installation to do. You break down the existing drywall. If it's like a bay window or some kind of porch overhang, you take the soffit down, you expose the floor. That's probably going to be cold. You put an R31 in there with spray foam, and then it does everything that we talked about before, whereas it's acting as an air barrier, so you're not going to have drafts in there. It's going to get rid of the cold floors. The wind won't be blowing through the insulation, bypassing all that insulation you're putting in there. And it makes the inside area over that room more comfortable. And starting to transition out into the exterior, again, depending on what kind of retrofit you're doing, this is starting to get more extreme where you're taking the facades off, putting new fascia on or something like that. You're getting to the actual exterior substrate. Well, one of the things you can do that's pretty easy to do with spray foam is just spray onto the existing sheathing. It does a great air seal, great vapor barrier, continuous insulation. One of the little hiccups that you might run into though, which again, if it's an old building, is what's actually in those wall cavities. If you're not opening them up on the inside, what's in there? How are you affecting the building science? How are you affecting air leakage or vapor barrier properties from the inside of the building, condensation control, that kind of thing. So I'm going to turn it over to Brian now, who's going to talk about how to actually address some of that.
All right, so how we're going to address this is actually by looking at what we're going to call a case study. So this case study is going to be a deep energy retrofit done in a 1960s era home. The homeowner of this property is actually an employee of ours that saw this as a potential option, and we've kind of used it as I said, a case study to see the feasibility of a deep energy retrofit on a home of this era. So some of the products that are used in this energy retrofit, we're utilizing a graphite enhanced expanded polystyrene material. So a lot of people are familiar with expanded polystyrene. It's the white bead product. This product actually has a graphite powder that's actually integrated into the expanded polystyrene beads. And what it does is it actually enhances the R value slightly as well as providing some radiant resistance to that product as well. So we're using that actually as an exterior sheathing product. We're utilizing the medium density closed cell spray foam in the wall cavity. We're also doing the air sealing with the caulking between wood members, and that's those sorts of joints. And we're also looking at, are we flashing things properly? Are we flashing our windows and our penetrations properly? So this is the home we can see over here, the two-story home, slight cantilever of the second story to bring the brick on the first story flush with the lap siding on the second story. So a couple of things about this sort of a retrofit. You know, it is scalable. We'll talk about that a little bit later, but the big thing about this is we're going to be able to greatly increase the R value of this existing home without really changing much about it. The look of the home afterwards won't look much different, other than the fact it might have a new, it'll have a fresher face with new siding on it. But, you know, one of the big things that we're going to be able to do is make sure that the wall assembly is properly protected. We're improving the efficiency, the overall energy efficiency of that structure. But by doing that, we may be changing the science of how that building is going to interact with the environment, the indoor environment and the outdoor environment. So making sure that we have, you know, vapor barrier, the air barrier in place, as well as updating that insulation. You know, a home that was built in the 50s, 60s, is there insulation? What kind of insulation is in there? What is its existing condition? Those are all the unknowns that Chris talked about with just spraying or applying insulation onto the outside of the building envelope. Other things like updating electrical or maybe fixing some structural issues. You know, the idea of this system is actually to get into the structure of the building so we can make those updates. Obviously, we're using a lot more electronics. We have a lot more requirements for electrical and outlets now, so we can get into these open cavities and update electrical if needed as well. The other thing to talk about is the HVAC system. I know Chris talked about it, but working with an energy advisor at this point is also a key point, is to make sure that we're making sure that the existing HVAC system is going to be adequate for what this energy retrofit is going to provide. You know, we may have a greatly oversized heating system or cooling system for the home once this energy retrofit is done. So if we don't have the mechanicals properly sized to how our building envelope is designed, we can have comfort-related issues. We can actually have energy-related issues as well. Maybe the systems are going to short cycle, or we may not get the efficiency out of the mechanical system. So important to bring that into the mix when we're looking at a retrofit like this. The other side to it is the moisture. The building science aspect of doing an energy retrofit on an existing building is extremely important. We don't want to do something to this building envelope that's going to potentially cause damage to it down the road. So simple calculations like these are dew point calculations and condensation analyses that can take a look at this assembly and figure out where the dew point is going to fall based upon the physical properties of the materials in that assembly, as well as look at, based upon particularly the permeance, the permeability of the products in that assembly, whether or not we're going to potentially have moisture accumulating in that wall. So just to illustrate what's going on in here, this would be an analysis of a wall here in Toronto, and this is actually that retrofit wall. So we have our medium density closed cell foam in the wall cavity, we have our expanded polystyrene on the outside, and you can see our summer dew point falls towards the interior side of the wall, but within the closed cell foam. Our winter dew point here is still falling within the closed cell foam. As Chris talked about, our moisture drive is actually in the wintertime coming from the interior to the exterior. So it's moving from this side to this side. Well, excuse me. Yes, from our interior to our exterior. Because of where that dew point is falling in this case, the closed cell foam is actually providing, again, that vapor resistance so that we don't see any condensation. This is our impermeable plane right here, which means moisture can't penetrate and come in contact with that dew point. It means our wall is going to stay dry. That's indicated here in our condensation analysis, which shows that we don't have any condensation potential because of the fact we are controlling our dew point in this case. All right, so let's get into the meat of it. So this is that actual assembly under renovation. So in this case, the siding, the sheathing, exterior sheathing has been removed. In this case, this had a craft-faced fiberglass bat in it. That was removed. The wall was cleaned up. Electrical was updated. Some structural issues were taken care of as well. These are things that are hidden during that are hidden within these wall systems that we don't know about. Being able to get in there and do this level of a retrofit helps to ensure that those aren't going to be problems down the road. So once it's opened up, once it's cleaned up and everything's been updated, we can do the application of the closed cell spray foam. So in this case, we're working in a residential environment. We're working outside. As Chris said, we're atomizing the material. We're taking two liquids, mixing them together. That's going to create a mist. Unfortunately, that mist isn't all going to go onto the surface. Some of it does deviate during the spray application, and we call that overspray. And we want to control our overspray. So in this case, the contractor utilized this tarp over a scaffolding system to control that overspray. Making sure that the neighbors don't get upset about the process going on. But you can see on the inside here, you can see the foam being applied in there, completely filling up that wall cavity. So this is a 2x4 wall, now insulated to about an 18 to 20, depending upon how it can get in there in thickness. Do you want to say questions? Or I think we've got time. We can do a question now.
How many lifts are required to get the thickness that we need in a 2x4 or 2x6 wall?
So in this application, this is going to be done in 2 lifts. The product that was utilized in this application requires allows a maximum of 2 inches in a single pass. So in this application, which was right around 3 inches, they would have done an initial pass of probably around 1.5 to 2 inches. They would have let that cool down and then a second pass applied. So, kind of hard to see with the lights here. This is an area we want to kind of showcase, and this is going to be part of that cantilever. So this is a floor system that's now overhanging that first floor and is going to be prone to being cold, especially in the wintertime, right? So in this case, that cavity has now been completely sealed off and it's been well insulated with the closed cell foam. So now we're not going to have to worry about air, drafts, air movement, that sort of stuff. It's going to cool down that floor and end up causing a comfort-related issue in those spaces. Also, it's going to be sealed right to the top plate. Again, very hard to see, but right here is going to be the top plate of your first floor wall. We're sealing directly to that, so now we're not getting any infiltration of air or moisture in or out of our floor cavity space. And that's going to be the biggest problem in these rim spaces, is that air leakage, that air movement, and the moisture that's associated with that air movement is going to deteriorate these spaces. So not only are we improving the overall efficiency and comfort level, but we are also improving the durability of the structure at the same time. So here we can see the foam has been applied, it's been cleaned up here, the studs are exposed. After that, we want to make sure we do that critical air sealing. So the foam has sealed up that cavity. It's expanded into all the little nooks and crannies and all the little voids within the cavity space, but we have all these other gaps. Every time 2 pieces of wood touch each other, we're going to have a gap and a void there, which could allow air and moisture to move through. So we're using, as Chris said, an elastomeric polyurethane sealant or an acoustical sealant to go through and detail these areas. We're going to make sure that all of these wood-to-wood connections, and that could be maybe 2 studs connecting, maybe it's plates connecting. It could also be, in this case, where our plate and our subfloor, or where our subfloor and our rim connect together. We want to detail those joints to make sure that we don't have any air or moisture penetrating through those points. Once the details have been done, now we can get our exterior sheathing put back on. So in this case, we're using the expanded polystyrene as our insulating exterior sheathing. So one of the questions may be, what about structural, right? We took off potentially a structural sheathing. What are we going to do in that case? There is testing that is available that shows that the closed cell spray foam that's been applied in the wall cavity can actually provide the structural strength, the racking resistance that's needed for that wall assembly. So we don't actually need the structural sheathing on there to provide the racking strength, the structural strength that the building code requires. If, in case maybe a building inspector doesn't want to look at that, or maybe we have a special consideration to take into consideration, maybe high winds or something like that, we can do inlet T-bracing or something like that. We can still provide the structural strength without having to change the design at all. So in this case, the expanded polystyrene is put onto the wall system. In this case, the expanded polystyrene, which does meet the building code requirements for the weather barrier, the seams are taped, so the seams and joints are taped, and that is our weather barrier. You can put a sheet applied weather barrier on there if you would like, but it would kind of be a redundant system to some point, because of the fact that once these joints are taped up, it is a code defined weather barrier. So once our seams are taped up or our weather barrier is put into place, obviously we're going to need something to attach our cladding system to. The most common one is probably going to be like a 1x4 furring strip attached directly to the framing members. Pretty easy to do because of the fact that when we're fastening on our sheathing, we know exactly where our studs are. We're fastening our sheathing directly to our studs, so all our furring members just have to be placed basically over where we fastened our sheathing on with. There are some other options in terms of how we're actually going to attach that cladding. If we have maybe a brick system or a masonry system, we can utilize these washers and clips in order to attach our masonry to. There are some other options. In terms of fastening, a lot of people ask, what do we need to use? It depends upon the thickness of exterior insulation that you're going to utilize. If you utilize, say, an 1.5 inch expanded polystyrene, we can just use a standard framing nailer, and we can actually use these washers. The framing nailer will allow it to attach directly through the washer and fasten tight to the wall. If we start to go thicker on our insulation, a standard fastener may not be long enough. We may have to start to look at screws. Screws start to get expensive, especially when they start to get real long. One of the options that we found is actually these, they're primarily used for agricultural buildings, pole buildings and such, but these real large nailers will actually fire up to a 6.25 inch long nail. The nailer isn't light, but it's a lot cheaper. Just to put it in a quick perspective, a fastener coming out of this gun is probably going to cost you maybe around 10 cents. A screw of the same length is probably going to cost you maybe around $1. So it's quite a significant savings by going with a pneumatic nail fastening versus a screw. In terms of fastening pattern, we are going to follow the building code requirement for fastening, so that's going to be 6 inches on the perimeter and 8 inches in the field on our panels, and that's going to follow suit with fastening of our furring strips as well. So depending upon the level of the energy retrofit you're going to do, we may want to take a look at the window flashing, as I said. In the case study that we're showcasing here, the windows are actually newer. So the homeowner decided not to take the windows out or not replace the windows. So the flashing details were done such that it was flashed directly into the window frame itself, into the flanges of the window. If we're going a little bit deeper in our energy retrofit though, and the windows and maybe the doors are coming out, we can look at flashing, pan flashing, and flashing these penetrations better. One of the ways we can do that is actually by using an elastomeric sealant. So rather than trying to do peel and stick origami and try and get a sheet of peel and stick into the corners and try and wrap it properly into the opening. A better option is actually to use a fluid applied system. So this is actually put on with a sealant, a caulking gun. It's spread out. In this case, in this application, they do have a wrap weather barrier. That wrap weather barrier in this case is actually integrated. It's put right into the wet sealant. It's fastened in, and then the edge is terminated with some more sealant. So now your flashing is directly integrated into your weather barrier. This can be done also if we don't have that exterior wrap. We would just take the sealant and actually wrap over the edge and out onto the face of our exterior foam. Once our windows go in, we can now integrate our window directly into that weather barrier, that sealant that's now been spread onto the face of the exterior foam. So just looking at some of the details, just kind of showcasing this is something that we actually have kind of looked into and looked at some of the specifics. So we've created a number of details here, and I know they're not real easy to see, but key points to bring up here is all the red marks are indicating areas where it's critical to have that sealant, have the wood-to-wood connection sealed up tight. As well as, say, in a cantilever situation or in your rim joist situations here, making sure that we have a continuous seal there. And especially with these sorts of situations, maybe in an existing home, we want to make sure we have a little bit of a belt and suspenders approach as well. So we're using the foam on the interior side for our insulation, our air barrier, and our vapor barrier, but we're also utilizing the sealant on the outside to hit those critical points of entry so that in case we do have a failure, maybe of one particular part of that system, we're going to have a backup to make sure that we don't have that air or moisture intrusion. And so this is actually the picture that Chris brought up earlier, but I like to call this the attic insulation beam dip because we've got multiple layers of different type of insulation in here. So we've got our original insulation probably installed in the 1960s when the home was built. It's probably a cellulose of some sort. We have some remnants here and there of some pink blown in fiberglass. We also have maybe some more recent white blown in fiberglass sitting on top of it. Problem is though that all of this accumulates and compacts down. We also don't know exactly whether or not we have that air barrier and that vapor barrier in place. So if we're going to this level of an energy retrofit on the wall system, we don't want to leave the large square footage of that attic undone. So in this case, we can get in there, they can remove that existing insulation. Again, we can correct any maybe structural issues, ventilation issues, electrical issues that are going on in that attic space. We can put a proper air and vapor barrier down to improve the performance of the attic portion of this assembly, and then utilize a properly installed blown-in insulation or bad insulation on top of it to ensure that we know truly what our attic insulation assembly is like. I can't tell you what the R value of this is because we don't really know. It's multiple components coming together. You can't necessarily take an assembly R value out of that due to compression of the insulation, age of materials, and differentiation of materials. And as I said, this is a completely scalable system. It's all going to be based upon the budget of the client, right? So you might have a client that says, hey, I want to replace my insulation. Or maybe it's just, I want to replace my siding. Well, if we're taking the siding off, you know, how much more is it going to be to maybe improve the efficiency of the overall building? So in a scalable form, this can be done. 1.5 inches of exterior insulation is about the minimum that we would recommend, just to give us the performance, the cost to performance aspect. But in this case, in that existing 2x4 wall, we could put 3 inches of the closed cell foam in, 1.5 inches of the graphite enhanced polystyrene. That gets us an effective R value of about 19. And it's scalable. We can actually take this even into a net zero type of assembly, get 4 inches of exterior insulation, 3 inches of closed cell foam in the cavity. Now we're at an effective R30. You know, this is greatly reduced their infiltration rates. Most of the homes that would go through this level of an energy retrofit would probably come back with blower door numbers in the 0.7 to 0.5 ACH50. So very, very low air infiltration numbers due to the detailing that's going to be involved and the products that we're utilizing in this sort of a retrofit. So I guess, you know, that's kind of concluding what we've got here. We just want to touch on a few things before we take some questions. You know, some of the main things in terms of, you know, for those that are working with a homeowner that may be looking at doing an energy retrofit, you know, things to consider is, you know, the comfort of the home itself. You know, there is a hidden cost to comfort, I think, and it's something to take into consideration. A lot of people want to know what the return on investment is going to be based upon the level of efficiency upgrade they're going to do, but do take into mind that there is a comfort level to it as well. You know, when you're sitting by a wall and you're not getting radiated by cold in the wintertime, you know, that's not going to be a dollar amount necessarily to the homeowner, but the fact that they're not having to sit there with a blanket wrapped around them as they're sitting in their home is a value to them. So something to take into consideration, as well as with the drafts, the elimination of the drafts, the increased durability. That home is now going to last a lot longer because we've taken out the moisture side and the air infiltration side of that assembly. And it's an improvement in the investment of the home. You know, a home that has had the energy improvements done to it, a home that is more comfortable, can definitely be sold at a higher premium due to the fact that it has had that investment put into it. Do you want to talk about on the builder side?
Yeah, so it's, you know, the building codes are changing. As you're doing retrofit, there's going to be changes in the retrofit code requirements as well too, where you have to increase the R value, you're going to have to increase the air tightness. There's talk about doing mandatory blower door testing even on resale homes. So all this stuff, by addressing air leakage, is going to help increase the value of the homes. And it gives you freedom of design as well too. If you're doing additions with curved architecture or something like that, then the spray foam is very versatile. It's going to stick to most components in the building envelope that's typically used, and it's going to get that insulation in there. And again, the air tightness, we've been hitting home on that quite a bit. You know, the R value is one thing, but it's because the foam gives it that air tightness. That's where the big benefits of the product comes into. And, you know, lastly is you're using knowledgeable certified trades. They know what they're doing. They do this every day. They're trained, they're tested to make sure that they know how to show that they know how to follow the manufacturer's guidelines to make sure that you have a seamless installation. So at that, you know, we'll open it up to questions. I think before we start, if there's anything that you come up with afterwards, is we got a generic email address, plan to use purple@basf.com. Fire us an email later on and we'll get you an answer regarding your questions there. So, yeah.
Are you aware of which OBC provision in our code recognizes the role of the spray foam as obviating the need for plywood because of its inherent racking strength?
The OBC itself, the racking strength requirements is actually coming from the drywall. in there. So it's the temporary bracing where you're looking to use the T-bars, that kind of stuff during construction itself. We've done engineering structural testing. We actually have engineering reports that are available. You can send those out to you that show that the spray foam going into a stud assembly and these kinds of assemblies is actually a lot stronger than a traditional OSB and drywall 2x6 wall.
Will we see recognition of that?
The OBC doesn't really call out for that, is my interpretation of it.
And which provision of the OBC recognizes its function as an air barrier?
Again, there's no provision that says this is how you must do an air barrier system. The OBC asks for ULC 741 and 742 testing. And again, it's up to the manufacturers to get that type of testing and show air barrier system compliance. And so, yeah, we do have that type of data as well, too. And there's a provision in the code that's basically identifying that if you do sealant in the joints, it's coming along. It's not there right now, but it's something that's going to be coming along with the sealant. So again, put it on the drawings and the building inspector should be okay with it.
I was taking the task courses last week, and they actually mentioned specifically that they don't recommend relying on spray foam or air barriers over the long term because I think they had some concerns about the possibility of cracks opening up between the spray foam and whatever studs they were sprayed against. I'm wondering if there's been any kind of long-term testing on the integrity of the system.
The product's been used for over 40 years in that regards. We had lots of durability testing, that's flexing the walls to see if there's any cracking and that kind of thing happening before even doing the air leakage testing. That's part of the 742 requirements is this product durable, and the walls actually shift during this testing, so there is movement involved in that. A lot of it probably comes down to making sure that the building is properly built and properly dry to make sure that those studs don't have a high moisture content in them, and also to make sure that's why you want to use a certified installer to make sure they're installing the product properly.
Yeah, and that's the big one that I would bring up is the installer. The medium close cell foam has a certain level of flexibility to it. It's a urethane, so for those that are familiar with other urethane adhesives like Gorilla Glue, it's going to bond extremely strong to what it's been applied to. We run into a lot of cases where people are asking, how do I remove it from this product? In terms of adhesion, it's going to be there and there is flexibility, but it comes down to how the product has been applied. If it hasn't been applied properly, that's going to be the time where you may have a result of a crack or something forming or a delamination. It's probably due to improper processing or an improper application. So that's why the installer is so important. Spray foam is virtually the only product that is manufactured on site. And that's why it is so important. The manufacturing process isn't in a controlled manufacturing facility. It's there on the job site. It's happening with the equipment that applicator is using. So that's why having a trained certified installer is so important, is that they need to understand the quality side of the product that they're putting out. So one back here first.
Question. Conventionally, we have a 6 mil poly that acts as a vapor barrier, and that forms a continuous sort of sheet across. If you're going to use spray foam and that goes between the studs, how do you account for vapor permeability right through a stud?
The stud itself, they're a vapor barrier. They're less than 60 nanograms as well, too. Okay. So there's continuity there with that regards. Basically just the cracks. And again, for vapor permeance, you're not too concerned about the joints between the wood studs. It's more so from an air leakage standpoint. You want to make sure that those joints are addressed. Yeah.
With respect to sub-slab application, I've done some reading, and some of the building science guys are saying that the air between the gravel kernels or stones is about 99% humidity. Would you still recommend a vapor barrier being used with the SPF?
So, yes and no. The spray foam itself can act as the vapor barrier, and due to its permeance level, it will mitigate the moisture as it's trying to permeate through. The bigger thing becomes the need for drainage and now the requirements for radon mitigation and that sort of stuff. So even a passive radon mitigation system will actually help to diffuse a lot of that moisture potential. And because you have a release point for that moisture as it may potentially build up, it'll find the path of least resistance, which is hopefully going to be either a drainage system or like a radon mitigation system, something like that. If you don't have a system like that installed, you could potentially put, say, a puncture-resistant polyethylene down. The only thing is foam doesn't actually adhere to polyethylene very well. So typically you would have to put the polyethylene down and then, say, put a small layer of gravel or something like that over it to actually create a ballast for the spray foam to sit onto. So you can do it multiple ways, but the majority of the time we see it done utilizing a drainage system to help diffuse the moisture potential and just utilizing the spray foam as that vapor barrier. Yes?
The second last question, I was going to ask the same one.
Okay.
And I recall a job years ago where an inspector insisted that on part of the house that was spray foam, he insisted that a 6 mil vapor barrier go over that area. Is or can that cause issues down the road by actually having that 6 mil vapor barrier?
In a properly built, properly constructed building, no.
Okay.
It's the double vapor barrier is not a concern because there shouldn't be any moisture. Like, you don't want moisture during construction before you put your 6 mil poly up anyway. So spray foam's there. There shouldn't be any moisture to begin with. You put your 6 mil poly up, you're not going to have any moisture in there to begin with anyways. So that's just conditioned space. It's warm room temperature space there.
So it's basically redundant.
Yeah.
To do it, but maybe
Yeah, exactly. How much, it's probably $1,000 for 6 mil poly. How much effort do you want to do to combat the building official on that? So, yep.
Oh, I just wanted to reinforce something that Chris and Brian brought up. If you decide to use closed cell spray foam on your projects, they talked about including it on the permit drawings. Include the standard for it. So closed cell spray foam insulation and the CAN ULC standard, the S705.1. If you include that reference, then most of your issues with building officials will go away. If you don't clarify it, they might think you're looking to use open cell foam or some other foam. But if you're specific, then most of your building code issues, building review issues will go away. We've done the training all around that aspect of it being included, so you're just closing the loop.
Good point. One more? Yeah.
The sheet that showed the multiple details, is that available for us to find on the website?
It's not on the website yet. It's fairly new, but yeah, we can make that available. We can send those out to you.
So where do we find it? SPF?
Give us your card. We'll get it out to you.
Yeah. Actually,
Yeah, it'll be part of,
card,
I guess the presentation is going to be on YouTube, so you won't see it too much there, but yeah, we can get those out to you.
Yeah.
They're hot off the press, so that's why they're...
Yeah, we've actually been working with Enercan on a retrofit option, so that's where a lot of this has come from the retrofit standpoint. Yeah.
There, after installation, is there any concern for off-gassing with spray foam? And if so, is there a certain test that you need to ensure that it's being installed adequately?
Again, that goes to getting the proper installer to begin with to make sure that they know what they're doing and making sure that the area is properly ventilated during application, which a certified installer knows. They're installing as per manufacturer guidelines, and that's why a lot of the manufacturers get the Green Guard Gold testing to show that this is a safe product to use. So there shouldn't be any concerns. I don't have any concerns on a properly installed product. If it's misapplied, then it comes down to trying to figure out how is it misapplied, doing an inspection, looking at the foam itself. That's basically doing a visual inspection on the foam is going to give you a much better idea than trying to do some kind of chamber analysis or something like that. So.
Yeah, the Green Guard Gold certification that requires VOC emissions testing and that sort of stuff. So the product for long-term VOC emissions has been tested and proven to be, not an issue. But yeah, it all comes down to how the product is applied, and if it's been misapplied, it's like anything else that if it hasn't been done right, you don't know what may or may not happen with it. So, all right, I think this would have to be our last one because I think we're almost out of time.
How many years have BASF done wall tight? Produced it?
Started in the 80s with the actual brand name itself. The spray foam standards were developed in the 1980s based on field-proven performances from back then, along with National Research Council, Health Canada, and all that kind of stuff to develop these ULC standards back in the 80s. So, and we've been involved since that time frame as well, specific with spray foam.
And BASF as a company has been involved with spray foam since the early 70s. So, yeah, we're coming up on over 40 years, almost 50 years in some of our markets for use with spray foams. All right, we'll do this one for the last one.
How does spray foam perform as far as sound insulation versus, like, say, rock wool or something like that?
Well, open cell is going to be comparable because it's very similar properties to a rock wool. Closed cell foam, it's going to transfer sound through it a lot more, but it locks everything down, so it stops those rattlings, the lower rumbles to it. So,
Let's say like traffic noise or something like that.
it's going to stop. It's going to quiet a truck driving by, but it might not quiet down somebody talking.
Yeah. It's sound transmission is airborne transmission or structural transmission. So it's an air barrier, so it stops the airborne sound transmission really well. But yeah, because of the density of the closed cell, those structural vibrations can work their way through and vibrate through the product. The open cell, as Chris said, is much more. It's closer to a mineral wool or a fiberglass or something like that, where it's able to absorb that sound wave and deaden it so it doesn't pass through nearly as much in a structural manner. So we've done STC, NRC testing, that sort of stuff that looks at basic wall assemblies. But I can tell you from experience, I've got something very similar to this in my own home, where I've got the foam on the outside and the closed cell in the cavity. I live by a highway, and I don't hear very much other than the semi that's putting on the coals and roaring away. That's about all we really hear even in the middle of the evenings.
So would you do a hybrid of the closed cell and the open cell then on the inside of the wall?
You could potentially. We see that a lot in like home theaters and that sort of stuff, where they'll utilize a combination of materials. Not even necessarily open cell. They may use a combination of closed cell and say fiberglass or mineral wool or something like that in order to get some of the sound deadening properties of a fibrous insulation at a much more cost-effective point, and then utilizing the closed cell foam for the air sealing and potentially maybe even some of the energy aspects and that sort of stuff.
I think at that we're probably over time. No one's opened the door yet, but
yeah, we got a wave about 10 minutes ago that we had 5 minutes. So
yeah, thank you all for attending. Any questions? Feel free to come up to us afterwards.